Good morning. I'm going to teach you again the topic on moment of force. So let's have the basic from the start. So, example here, what is the moment about O for each of the cases as shown in the figure? So take note that for us to compute for the moment, it should be that you have this, let's say this moment arm, you should get this perpendicular distance. Okay, so it should be perpendicular and then distance should be this one. Okay, so as it rotates about here, so you have here moment O is just 50, okay, Newton multiplied by, this is the distance, 16 centimeters. Okay, so you can have this as 800 Newton centimeters. Now if you would like to convert, you know that 1 centimeter is equal to, or 100 centimeters equal to 1 meter. So if you divide this one by 100, you have in meters. Okay, so this is just a basic conversion. Newton meter. Okay, so take note that it is always the force has a perpendicular distance. So for in this case, there is no perpendicular distance here. Okay, no, there's a perpendicular angle, I should say. So what you need to do is to get the components. Say this one, you get to have the vertical component here and then this horizontal component. Take note that the angle is along with this side, so meaning at this side that is cosine. So let's say you have this triangle, if this is theta, this one should be cosine and this one should be sine, considering the theta. Okay, that angle opposite is sine, side is cosine, so meaning this one is 81 cosine of 15. However, this one is 81. Of course, this becomes sine of 15. But take note about the moment. Okay. So here, there is this, okay, 90 degrees angle. So obviously, this one, you can have this distance. But in this case, this horizontal is going towards this O, this rotation. So, by the formula that force and distance moment here for this particular force times distance here is equal to 0. In other words, all the forces going to the point of rotation is 0. So our moment here is only for this component. So you have 81 cosine of 15 multiplied by this 3 meters. Okay, your unit should be Newton and meter. You just calculate. Okay, then you can get this value. Okay, how about this one? So again, this one, if let me extend this line, okay? Also this one. So in other words, this angle is also the same with this. This is 30 degrees. Okay. Now, how are you going to get the components? There are a lot of methods, okay? That you could get the components. For this case, since we need, okay, this angle, so you can have this vertical. This should be the vertical or component, or the component along this direction, and then you have also here another component. This one is the same as having here. Okay, just for this purpose, so that we could write, you know, this opposite of 30. So this is zero point 0.5 opposite or sine 30, and while this one is, of course, it's adjacent, this is zero point 0.5 cosine of 30. Okay, so you follow me? Okay, so take note again that you have this 90 degrees here. Okay, this is the same as here. You can move it here, zero point 0.5 sine 30. In other words, the distance that you could use for this force is 40 meters. While this one, again, the force is along with the angle of rotation. So the moment generated by this force is zero. So you have moment, we only use this one, zero point 0.5 sine 30 degrees. This is the force multiplied by the distance, which is 40. Okay, force here is uh, kilonewton. This is kilonewton, and distance is meter. So your unit here, 0.5 and sine 30, and then 40 just equal to 10. Your unit is kilonewton and then meter. Okay, so how about this one? We need, if you're going to extend this one here, also this one, there should be 90 degrees here. Just looking at this point, you have this triangle, right? This is your triangle, this is 30 degrees. So meaning you can get this, let's say this distance, okay? Let's say this x. X is just a cosine function because it's adjacent to 30. So that means you have 60 cosine of 30 degrees. This becomes your distance. Since this is the perpendicular, uh, or this is 90 degrees, you have perpendicular here. So moment at O is just this force, which is 200. 200 times, okay? You have this 60 cosine 30. Using your calculator, you can get the answer. Your unit will be in Newton and millimeters. Okay, Newton and millimeters. Now, if you are going to divide by 1000 millimeters, okay, to make it meter, so meaning our answer, if you use your calculator, that becomes 10.39 Newton meter. Take note that 1 meter is equal to 1000 millimeters. Okay, so I hope you get it. Now you have this. Okay, for this one, the condition is to calculate the moment of this 90 kilonewton provided that the theta is 15 degrees. This one should be 15 degrees. Okay, so let's compute for the moment. So you have this vertical component, which is adjacent to theta, and then horizontal, which is also here. Okay, horizontal is here. Okay. So for your vertical, you have 90. Okay, this is the side, so meaning that is adjacent, cosine theta, which is 15. And then this part is just the opposite, which is 90 sine of 15. Okay, so if I'm going to draw it here, you have here O, this point. Okay, this is the free body diagram. You have here, I can write it here. This is 90 cosine 15. And then the other force is this one. You have 90 sine 15. Okay, let's get the distance. Okay, okay, for this 90 sine theta, if you are going to rotate going here, so that is clockwise. Okay, clockwise meaning positive. Its distance, which is perpendicular, should be this one. Okay, 800 millimeters or zero point 0.8 of a meter. Okay, whereas, so you can write moment at O, 90 sine 15 multiplied by 0 0.8. Okay, the other one, this one is going here, and it is already anti-clockwise. The distance should be this perpendicular distance. Okay, so you have this as 0.6 or 600 millimeters. Okay, but this one is anti-clockwise, so meaning that's negative. 90 sine of 15 multiplied by this zero point 0.6 of a meter. Okay, so you can find, if you use your calculator, it should be the value. It should be negative 33.5. Unit is Newton, and then meter. Okay, let us compute letter B. Okay, for letter B, the question is to compute what would be, okay, the moment, or what would be, okay, what would be the value of angle when moment is equal to 0. So, when moment is equal to 0, it should be that the force has no distance, perpendicular distance, with regards to the rotation. So, in other words, if this is your rotation, force should be go directly towards here, so that there is no, so that there will be no moment arm. Okay, so this theta, okay, this one should be your F, and your theta should be coming here. Okay, so your theta should be here. Okay, in other words, this is your O, your F should be in this direction. Okay, so this one is your theta. This is the question to compute for the theta. Obviously, your theta is just inverse tangent. Theta is inverse tangent of opposite. Okay, this is 600 or zero point 0.6. You can have it, or zero point 0.8 here. So this is zero point 0.6 by zero point 0.8. Okay, so theta would just be easily calculated, equals to 36.9 degrees. Now, let us see what would be the maximum, what would be the angle that you can have to get a maximum value of moment. Maximum moment in this case should be, if you have this triangle, this is your O, maximum moment should be at a certain perpendicular direction out of this plane. So if this is theta, that angle is theta from the horizontal. So what you need to show is this part, okay? This is your F. There's a perpendicular or 90 degrees angle here, perpendicular to this line, okay? So that gives you a maximum moment. Okay, so let's have this one next. So in this case, you are going to compute, just with this problem, you have a certain T, so we are going to calculate, and then which will cause no bending of the mass. So if you're just going to equate them, you can find the value of T, okay, which will no cause no bending at here, or zero moment. So meaning moment at O will be zero at this point. So you have components that you're going to use. So here, this component, and then this component. Okay, also this component, and then this component. Okay, and the distances, it's easy to, okay, identify, because you just have to connect like this. The rotation is here. Okay, but first, this angle, what would be this angle? Okay, that angle is just reverse, inverse I should say, of 5/2. Actually, you can work with the slope, but some of you could have difficulty in doing such yeah, calculation. So you have here 68.2 is this angle. So this is theta. Okay, so moment here at O is equal to 0. So we start with this, okay, positive values. This is T going to, okay, this T is going here like that. It's clockwise. Okay, perpendicular here. So this is the distance for this part. Okay, this actually T, if this is cosine theta, so this become, oh, this is theta, so meaning this is cosine of 68.2. So you have here T cosine of 68.2 Okay, I'm going to multiply with this distance. Okay, 60 millimeters. Okay, you can have here 60. Okay, how about this one? The direction of this one is going here. It's also clockwise, and then there the perpendicular distance is 120. So this function here is opposite of this angle. It's the same as here. Okay, so this function here is t sine of 68.2. So it's also clockwise. You can have plus t sine of 68.2 multiply by, again, as I said, this is the perpendicular distance. As it rotates going here, it's 120. Are all using millimeters. Okay, and next you have this one. We consider first this one. Okay, okay. This is 30. This part is supposedly the adjacent, so this becomes 5 cosine 30. So this is going towards here, that becomes anticlockwise. So this is negative 5 cosine 30. Okay, multiply by distance. This is the rotation going here. Take note from here, so the perpendicular distance is here. So this should be 90. And then how about this one? This function. What is this function? It is just the same here, opposite of this one, of this 30 degrees. So this is 5 sine of 30. So the movement is going here. It's also what? Anti-clockwise. So that also negative 5 sine of 30. Now its distance is this 60. You have here this perpendicular distance, and this is 30. No, it's 60, I should say. Equals to 0. You use your calculator, you can come up with the value of t. Okay, value of t is supposed to be 4.04 kilonewton. I want you to check this one. Okay, use your calculator. So that's all for the moment of force. I hope you understand this one. Thank you.